Dr. Rhonda Patrick here. In my last video and accompanying article, I discussed growth hormone and IGF-1 and their performance longevity trade-off. On the one hand, as a downstream mediator of growth hormone, IGF-1 has many positive effects associated with youth, such as decreasing fat while increasing lean muscle mass, increasing verbal memory, and increasing neurogenesis, the growth of new brain cells, and also promoting muscle repair. On the other hand, mice, worms, and flies that are genetically engineered to have high levels of growth hormone or IGF-1 have substantially shortened lifespans, hence the trade-off. Heat acclimation through sauna use, a term that I call hyperthermic conditioning, can help achieve and give you many of those positive effects associated with IGF-1 without the risk of high levels of growth hormone or supraphysiological levels of growth hormone that's associated with growth hormone therapy. Today I'm going to discuss how acclimating your body to heat through using something like the sauna, either in conjunction with or independent of exercise, can induce physiological adaptations that can help improve your endurance performance and the acquisition of muscle mass. In addition, I'm going to discuss how heat acclimation actually has very interesting and positive effects on the hypothalamus and neuroendocrine system, many of these impacting brain function, including neurogenesis. Lastly, I will discuss how heat acclimation or modulating your core body temperature may also be responsible for the term known as the runner's high. So let's begin with the endurance enhancements. First, heat acclimation increases the blood flow to your skeletal muscles. This increases glucose, esterified fatty acids, and oxygen to your skeletal muscles. Oftentimes, during endurance training, your skeletal muscles will deplete these nutrients, and then they have to rely on local glycogen stores. Anecdotally, endurance athletes often talk about hitting a wall. Well, this in biological terms is referring to when your muscles have depleted local glycogen stores. In fact, it's been shown that heat acclimation reduces the need to rely on glycogen stores between 40 and 50% as compared to not being heat acclimated. Second, heat acclimation increases blood flow to the heart. This lowers cardiovascular strain and lowers the heart rate for the same given exercise workload. These things allow physical activity to be maintained for a longer period of time as compared to not being heat acclimated. Third is heat acclimation increases blood flow to the skin and it activates the sympathetic nervous system, which allows sweating to occur at a lower core body temperature and to be maintained for a longer period, therefore lowering your core body temperature. It also releases norepinephrine, which is a vasodilator, among other things, and allows for heat to be dissipated more efficiently, also lowering the core body temperature. So let's take a step back from these nuts and bolts and talk about what kind of endurance gains you can expect from heat acclimation through sauna use. In one study, male runners engaged in a 30-minute sauna session 2 times a week after their workout. These runners were able to increase their running until exhaustion by 32%, and they experienced an accompanied 7% increase in plasma volume and 3.5% increase in red blood cell count. It's thought that the increase in red blood cell count was due to a compensatory mechanism for the increased plasma volume, and possibly through erythropoietin. Heat acclimation through sauna use can also have positive effects on muscle hypertrophy, that is, gaining muscle mass. Muscle hypertrophy mostly relies on increasing the size of muscle cells, which depends on increasing protein synthesis. Exercise is a well-known inducer of muscle hypertrophy because it increases net protein synthesis, but unfortunately it also has to combat the effects of oxidative stress, which increases protein degradation at the same time. So anything that can combat oxidative stress during exercise will result in a net increase in protein synthesis and thus muscle hypertrophy. There are 3 ways that being heat acclimated can increase muscle hypertrophy. First is through the induction of heat shock proteins. Second is by boosting growth hormone levels. And third is by improving insulin sensitivity. Heat shock proteins, as their name implies, are induced by heat. This robust induction of heat shock proteins upon heat exposure is a prime example of hormesis. Heat shock proteins are able to repair damaged proteins and prevent protein oxidation by scavenging free radicals and by increasing endogenous antioxidants in our body, such as glutathione. And this is how they are able to cause a net increase in protein synthesis. Acclimating your body to heat can also result in higher basal expression of heat shock proteins, as well as a more robust induction during later elevations in core body temperature, such as during physical exercise. In one study in rats, hyperthermic conditioning resulted in a robust induction of heat shock proteins, and this correlated with 30% more muscle regrowth compared to controls after 7 days of immobilization. The second way heat acclimation affects muscle hypertrophy is through the release of growth hormone. The anabolic effects of growth hormone are well known. For example, growth hormone administration to endurance athletes for 4 weeks resulted in 50% less protein oxidation and degradation, thereby increasing muscle hypertrophy. But what's not well known is that the sauna also affects growth hormone levels. These effects depend on the temperature, time spent, and the frequency of sauna use. For example, 2 20-minute sauna sessions a day at 80 degrees Celsius can result in a 2-fold increase in growth hormone levels over baseline. But perhaps what's more surprising is the profound effects that frequency of sauna use can have on growth hormone levels. And this really highlights the physiological adaptations that occur as a consequence to hyperthermically conditioning your body to heat. 2 1-hour-a-day sauna sessions at 80 degrees Celsius for 7 days in a row resulted in a 16-fold increase in growth hormone levels over baseline in men. That's pretty huge. The third way in which heat acclimation can promote muscle growth is by improving insulin sensitivity. Insulin is anabolic because it decreases protein degradation, much like heat shock proteins and growth hormone. Whole body hyperthermia has been shown to reduce insulin resistance and improve insulin sensitivity in an obese diabetic mouse model. What's also interesting is that heat stress, which is known to boost growth hormone levels in humans, has been shown in flies and worms to cause about a 15% increase in lifespan. Now, this is counter to what you might expect if you watched my last video on the performance longevity trade-off. The reason for this is that heat stress induces hormesis, and that causes the increase in expression in genes and proteins, such as heat shock proteins, that are known to improve longevity. Intermittent heat exposure and heat acclimation also have positive benefits on the brain. These positive benefits include increased neurogenesis, improved learning and memory, and improved focus. Sauna-induced hyperthermia also has a profound effect on norepinephrine and prolactin levels. In one study, individuals that stayed in the sauna until exhaustion had a 310% increase in norepinephrine and a 10-fold increase in prolactin levels. Norepinephrine helps with focus and attention, and prolactin is important for myelin growth. Myelin increases the efficiency of the electrical activity in your brain and is also important for repairing nerve cell damage. In addition to increasing norepinephrine, heat acclimation also increases the biological capacity to store norepinephrine for later release. This is very relevant for disorders such as ADHD, which is often treated with norepinephrine reuptake inhibitors and is associated with decreased norepinephrine release during exercise. Heat stress also increases neurogenesis. Hyperthermia, in conjunction with exercise, increases the expression of brain-derived neurotrophic factor, BDNF, even more so than exercise alone. BDNF is often referred to as a miracle grow for brain cells because it increases the growth of new brain cells and it promotes the survival of already existing neurons. BDNF also increases neuronal plasticity, which is important to learn new information as well as to remember and retain that new information. BDNF has also been shown to decrease depression and anxiety associated with early life stressful events. And if that weren't enough, BDNF can also be released from your muscle cells, where it promotes muscle repair and the growth of new muscle tissue. All I can say is, wow. A couple of other interesting facts about physiological effects of heat stress. Ever wonder what's responsible for the runner's high or the post-exercise high in general? You may think it's due to the release of endorphins, but that's not the whole story. Endorphins, also known as beta endorphins, are a part of the body's natural mu-opioid painkiller system. This is the same system that potent narcotics like morphine interact with. What you may not be familiar is the counterpart to this, the kappa opioid system. Dynorphin is responsible for that feeling of dysphoria. It is the opposite of endorphin. The discomfort experienced from intense exercise, heat stress, or even eating spicy foods is due to the release of that dysphoric opioid dynorphin. It is the release of dynorphin that causes your mu-opioid receptors to become sensitized to that feel-good opioid endorphin. Hyperthermia from sauna use increases dynorphin levels and subsequently endorphin levels even more than exercise alone. Did you retain all that awesomeness I just threw at you? Okay, let's have a quick recap. Heat acclimation through sauna use, a term I call hyperthermic conditioning, has been shown to improve endurance by increasing nutrient delivery to your muscles and thereby reducing the need for glycogen stores, by improving cardiovascular mechanisms and reducing heart rate, and also by improving thermoregulatory mechanisms and lowering core body temperature. It's been shown to improve muscle hypertrophy by preventing protein degradation and thereby causing a net increase in protein synthesis from the following three mechanisms. One, by inducing the expression of heat shock proteins, which also are induced from a hormetic response that has been shown to improve longevity in lower organisms. Secondly, by increasing the release of growth hormone. And thirdly, by improving insulin sensitivity. Hyperthermic conditioning through sauna use also has important positive effects on the brain. It increases the release and the storage of norepinephrine, which is important for focus and attention. It increases prolactin, which helps your brain function faster through myelination, which is also important for repairing damaged nerve cells. In addition, it increases BDNF, which increases the growth of new brain cells. It is important for learning and memory, and also helps decrease depression and anxiety that's associated with early stressful events. Lastly, it also increases the expression of dynorphin, which sensitizes your body to the feel-good endorphin. I believe that hyperthermic conditioning in general is worth a closer look as a tool in the tool belt of athletes, beyond its more traditional role as a means of relaxation. Because hyperthermic conditioning works by inducing stress in order to build stress tolerance, it should definitely be used with some level of caution and common sense, particularly with regards to your own unique body chemistry. Here's one more thing for you CrossFit people out there. Heat stress has been shown to increase the expression of heme oxygenase 1, which as it turns out is also known as heat shock protein 32, and has been shown to protect against the toxic effects of rhabdomyolysis in rodents. I'm Dr. Rhonda Patrick, and I'll catch you next time.